Hello everyone, welcome to this video. In this video, we shall be talking about a question from IIT-JAM 2019, which is consisting of 2 marks and it is a numerical answer type question. So the question here, it says that find the number of critical points for this given function. So this function is given to us and we are to tell how many critical points does this function have. So for that, first of all, you should know what are critical points. So these are the possible points where the function could have either maximum value or the minimum value. So we are to count how many such points are there for this function. So the procedure to calculate this maxima and minima would also include calculation of this critical points. So for that, if you have some function in two variables f of x and y, so what you do, you calculate the partial derivative of this function with respect to x, with respect to y, and then you substitute them individually equal to 0. So you have two algebraic equations. You solve these two equations simultaneously and calculate the values of x and y. So whatever are the values of x and y, they constitute the critical points. So we need to see how many such points are available for this particular function over here. Okay, so for the solution here, let me write down the function. This is given to be x square plus 3y square multiplied by e to the power minus x square plus y square, right? This is the function. So let me take the partial derivative of this function with respect to x. So that means I am applying the product rule onto these two terms containing both x and y. So here we'll treat y as constant. So when you perform the derivative of the first term, it would be 2x. Second term would come as such, and then in the second we have plus first term as such, and then the derivative for this second term, which would be minus 2x multiplied by e to the power minus x square plus y square. So we can substitute this term equal to 0 because that is what we are required to do over here. So when you substitute this equal to 0, so let me rearrange that. I can take this e to the power minus x square plus y square term as common. So I'll be left with 2x multiplied by, here also I have 2x. So I'll be left with x square plus 3y square minus 1 is equal to 0. Now this thing cannot be 0 because this is a positive function. So you only have either x is equal to 0 or x square plus 3y square minus 1 is equal to 0. So these are the two possible cases. So let me mark this by first and let me mark this by second, right? And similarly, we'll calculate the derivative partially with respect to y for this same function. So when you calculate the partial derivative with respect to y, so it would be 6y multiplied by e to the power minus x square plus y square, and then you have plus this term as such x square plus 3y square, and then the derivative would be e to the power minus x square plus y square multiplied by minus 2y, right? So again we'll substitute this term is equal to 0. Therefore when you rearrange and simplify this a bit, so you can take this 2y common from here, from both the terms. So you would be left with 3, right, minus x square minus 3y square into e to the power minus x square plus y square is equal to 0. So now this term cannot be 0, being exponential function, that is always a positive quantity. Therefore we only have either y is as 0 or 3 minus x square minus 3y square as equal to 0. So this is the third term over here and this is the fourth term over here. So now for the critical points, you may either have this term with this term or you may have this term with this term, right? So this is the second possibility, red term. So let me talk about this first possibility first. So let me take cases. So for the first case, either you have x is equal to 0 and you have y is equal to 0. So that means your point here would be what? It would be 0, 0. So this is the first critical point that you obtain. Now talking about this second possibility where you have x as 0 and you have 3 minus x square minus 3y square as equal to 0. So when you solve these two equations simultaneously, you obtain y as equal to plus minus 1. You may check that. Therefore, the points here, they are 0, 1 and 0, minus 1. So therefore, you have your second and third critical point from here. Right? And next, what other possibilities do you have? So you can also take the second term of x and you may take this first term for y. So that means in the third case we have, so case number 3, you have this possibility of y0 and x square plus 3y square minus 1 is equal to 0. X square plus 3y square minus 1 is equal to 0. So when you solve these two equations simultaneously, you obtain x square minus 1 is equal to 0, or you have x is equal to plus minus 1. Therefore, the points here that you obtain are 0, 1, or you have minus 1, 0. So that means you got your fourth and fifth critical point from here. Right? And for the last possibility, in the last case, you have this situation that you may either have this term and this term together. So that means when you solve this case, so let me write down here case number 4. So in case 4, you may have x square plus 3y square minus 1 is equal to 0, and simultaneously you have 3 minus x square minus 3y square is equal to 0. So from here, if you calculate the value of x square plus 3y square, it comes out to be 1. And from the second equation, the value of x square plus 3y square comes out to be 3. So that means 1 should be equal to 3. But this is never true. Therefore, this case is not possible. So we got our critical points as 0, 0, 0, 1, 0, minus 1, 1, 0 and minus 1, 0. So therefore, in total, we have 5 critical points with us. Therefore, the solution to this question over here is 5. So in total number, we have 5 critical points for this particular function. So I hope you understood this question well. Well, that is it for this video. Thank you for watching.